Alright, so this is going to be our last video for this particular lesson. We're going to be talking about sectors of a circle. So it's kind of like the same thing we did when we started out with circumference last class, and then we ended up with arc length, which is part of the circumference. It's the same thing for area. We start off with the entire area, the total amount of space that's inside that circle, and now we're just going to talk about what happens if we cut a pizza slice out of it. And so at the top of page 239, you have what it says vocabulary, and then it says sector of a circle. So there's this real technical definition of it, and it makes sense to me, but I wanted to give you a definition that would stick with you. So here's my definition of a sector of a circle. A pizza slice shaped region of a circle. Now, by no means is that technical, by no means is that the textbook definition of it, but hey, that's how I remember it. A sector. Think about if you have a circle and you're cutting a slice of pizza out of it, a sector shape will look like this. Oops. Turn with me to page 240. On page 240, example 2, you see your first sector example. You see a circle Q in a one shaded region. It looks like a slice of pizza, and it has 63 degrees in that shaded sector. That shaded part, we call that a sector. But guess what? Every time you cut a slice of pizza, you leave essentially a bigger slice all around for the rest of the pizza. So you think about that one slice that you cut, and everything else is also what we call a sector. And basically, we call the shaded region, this is called the small sector. And then everything else, that big non-shaded section, what's left over of the pizza, we call that the large sector. So in this example, I'm going to show you how to calculate the area of a sector of a circle. Now, they walk us through step by step with a whole bunch of fill in the blanks, and sometimes I think that can be confusing. So what I'm going to do, off to the side, under where it says notes, I'm going to walk you through this process. And feel free to take your notes and follow along off to the side of the page like I'm doing here. So, take a look at that circle. What does it say the radius is? Well, you can see the radius is 5. And since we're talking about area, to me, I'm like, well, let me calculate the area of the entire circle first. So I know A equals pi r squared. So we know r is 5. So I can say A equals pi times 5 squared. Now, once again, I'm not allowed to multiply this pi with a 5 until I square the 5 first. So 5 pi squared is going to be the same thing. The area of this circle is going to be 25 pi. The area of this circle is going to be 25 pi. Now, here's the thing. We don't want to know the entire area of the circle. We just want to know, for now, what the small sector is. Just the shaded region. Well, here's how I think about it. Well, this isn't the whole circle. It's not half the circle, it's not a quarter of the circle, but I can tell exactly how much of the circle is consisting of this sector by the angle here. You see this 63 degree angle? Well, that's the central angle. How many total degrees are in a full circle? Well, 360. But we don't have the entire circle. We just have 63 degrees out of that entire 360. So if you want to represent this portion of the circle as a fraction, it would be 63 out of 360. Well, so now that we know that this is the fraction of the circle that we're looking for, I can take this fraction and multiply it times 25 pi. That's going to give me the area of the small sector. So, calculator, I'm going to show you, to me, the easiest way to get this out of the calculator. Well, I like to get this fraction into a decimal first. So on your calculator, press 63 divided by 360. That's going to give me a decimal. I get 0.175 as this fraction. And I multiply that times 25 pi. What's up with 5 pi? And so I have 0.175, and if I multiply that times 25 pi, I'm just going to put 0.175 times 25 pi. That's going to give me, when I multiply this entire thing together, it's going to give me about 13.74. 13.74 is going to be the area of that sector. All right? So, once again, I figured out what portion of the circle is taken up in the shaded region at 63 degrees out of an entire 360. The entire area is 25 pi, but I don't want to know the entire area. I just want to know what that portion is. So I do 63 divided by 360, and then I multiply that times the area. That's going to be my final answer, 13.74. Remember, with rounding, your answer may not be exactly 13.74. It may be 13.7, or it might be 13.78. But that's what happens when you round. So this is one example of how we find that small sector, the shaded region. But like I said, for every small sector, there's also a large sector. So let's talk about the large sector. I'll leave this up on the board. We already found that the entire area is 25 pi. I just want to put that out there. Now, you said there's 360 degrees in this entire circle. Now, I just want to figure out how much is left over in this unshaded region, the large sector, how much is left over for the white part. So, what am I going to do with that 360 and 63? I know anytime I'm trying to figure out what's missing, I'm going to subtract. You know, if you came to school with $360 and now all you have left is just $63, Jill season, if you want to figure out how much you're taking from you, if you want to figure out how much is missing, you subtract that 360 from 63 degrees. Sorry, excuse me, you subtract 63 from 360. And so when I do that, I get 297. 297 degrees are out here in that large sector. 297 degrees are in that total large sector there. Well, once again, I know my area is 25 pi, but I don't want to know what the entire area is. I just want to know what this portion is. So you guys told me that how many degrees were in a full circle? Well, we know 360. So I have 297 of those 360 degrees taken up by that large sector. So 297 out of 360, that's my fraction. That's the fraction of the circle that I'm looking for. I can take that fraction and multiply it times the area. We already found the area. It's 25 pi. So once again, using your calculator, I want you to multiply 297 over 360 times 25 pi. 297 over 360 is going to be about 297 over 360 is going to be about 0.825. And then I have to multiply that times 25 pi. So times 25 pi. I get 64.8. Just about. So about 64.8 for the large sector. So once again, you see how at the end of the day, I'm just looking for the fraction of the circle where I want to find the area, and I'm going to multiply that times the total area. I'll go through one more example. Everybody flip over to the next page where it says checkpoints. I take a look at the checkpoint where you see checkpoint number 2. So once again, they give me a sector. They give me a pizza slice shaped region of this circle. And they tell me this is 106 degrees. There's two sectors here. Notice that it says find the area of the sectors. There's two of them. Because I have my small sector and I also have my large sector. So let's find the area of the small sector first, and I'll let you find the area of the large sector. So what I think about it, well, let me find the total area of this circle first. What's my formula for area? A equals pi r squared. Well, I know r is what here? So r is 9. So 9 squared is 81. So I'll say A equals 81 pi. A equals 81 pi. It's 9 squared is 81. But that's the entire area. I don't want to know the entire area. If I want to find the small sector, the small sector fraction of that circle. It's only a small fraction. But specifically, how big is a fraction? What is the fraction? Well, I have 106 degrees here. And I know there are 360 degrees in my entire circle. So this is 106 out of 360. And I'm going to take this fraction, I'm going to multiply it times the entire area. So I have 106 over 360 times 81 pi. So I pick up my calculator, 106 divided by 360. In decimal form, this fraction is about 0.294. So this is about 0.294. And I'll multiply that times 81 pi. When I multiply those two numbers together, I get about 74.93. Now that's going to be the area of that sector. They give me units here, feet. So is this going to be 74.93 feet or 74.93 square feet? When we know, since I'm talking about area, this is going to be square feet. I put my feet, then I put a little square there. My final answer for the small sector is 74.93 feet squared. Now I want you to go ahead and find the large sector for yourself. Once again, we have to figure out what the total degree measure is for this bigger arc here. I know if I want to find out what's missing, I'm going to subtract from what I'm supposed to have. So I finished out that example. And then along with 1 through 7 on page 242, I want you to finish questions 8, 9, and 10. So total what I'm going to check for homework on Friday and Monday is questions 1 through 10 on page 242. Let me know if you guys have any questions. I hope this helped. See you soon.